Hello, everyone. Welcome, and thank you for joining this talk on build high-performance MLOps with ML monitoring and AI explainability with Amit Paka. My name is Faraz, and I'm one of the co-organizers here at MLOps. Just before we begin, if you do have any questions, please feel free to ask them in the chat so that we can collect them and then we can address them in the end. Please do visit our sponsors, including Fiddler, in the booth section that you'll find on the left-hand side. They have some very exciting giveaways. So it's my absolute pleasure to introduce Amit today. Amit is the co-founder and CPO of Fiddler, a machine learning monitoring company that empowers companies to efficiently monitor and troubleshoot ML models with explainable AI. Prior to founding Fiddler, Amit led the shopping app product team at Samsung and founded Parable, the creative photo network that is also now part of Samsung. He has also led PayPal's consumer in-store mobile payment, launching a lot of innovations, including the hardware beacon payment system, and has developed successful startup products, particularly in the online advertising space. So welcome, Amit, and over to you.
Thanks, Faraz. Excited to again be here in another installment of MLOps, and here in the Bay Area, coming to you virtually. Today, I wanted to focus more on talking about what does it mean to build high-performance MLOps, and deep dive into some of the ways to do that. And let me kick it off. We'll leave some time at the end for any questions that you might have. Feel free to push the questions as we go through the slides, and I'll address them towards the end. All right, so a little bit about Fiddler. We are about 3 years in now. Our mission, when we got started, was to build trust with AI. That still is the thing that really guides us. And a solution that I'll be talking more about today, I'll touch upon this approach called model performance management. It is something that sits on top of any data source and any model, and helps you get visibility into your machine learning models and ensure that they're running at high performance. So the focus of this entire conference is machine learning in production. So I wanted to get started on a key metric that likely a lot of folks in the audience have seen in the past couple of years, but it stuck around that 87% of all data science projects, they never make it into production. So that's an astonishingly high number. Why is that? There's a few key reasons. Number one is when kind of data science projects begin, they start as pilots, and they're not really tied to a business problem that needs to be solved. And so that's one of the reasons, as it goes into production, not tying to that business impact, it results in that project getting shelved and never making it into production. The second reason is while you can make these data science projects work well into like pilots, in like innovation labs, putting it into production needs a lot more considerations. Do you have, for example, data coming in at like a regular pace that you can make the product like really better, this model as good as possible? And so if that's not being considered in the pilot, it'll be very hard to push this model into production. Thirdly, teams view machine learning models as they're thinking about going through these pilots as really traditional software, because that's what they've been acquainted with. But it's very different, and we'll kind of talk about how they're different. But one of the key reasons is that these machine learning models have been built and trained on a certain set of data. And so when they see different data after being deployed, their performance can shift. And this can cause a lot of impact. And if you don't have visibility into it, the model performance can go down. And that's not the case with like traditional software. And in case of machine learning models, also you've got something called the black box effect, where machine learning models are becoming opaque, and that results in a whole lot of issues that you need to address as part of deployment of machine learning models. And lastly, machine learning model deployment process, or rather what we call MLOps, is very different from like traditional DevOps, from the likes of feature engineering or just looking at data gathering even before feature engineering, and then training, and then validation, deployment, and monitoring. So if there isn't a coordinated process in place, then that is also one of the final key reasons why data science projects never make it into production. Now, why do you want to monitor a model? So here's a clear kind of business case why you want to monitor your models. Machine learning is expensive as compared to traditional software. You've got to hire whole teams of data scientists to do it. And so it is expensive. And because it is expensive, teams are applying machine learning to the higher value use cases where they see a lot of time to the core, like the actual business metrics. For example, if you look at social media companies, their feeds are driven by like machine learning. The feed kind of recommendation models, and you can imagine how core that is to their business. And so, because these machine learning models need expensive teams, they apply to high value use cases. But once these models are deployed, they can fail really silently. You may not know when it's having issues, and they can decay over time. And so if you're not monitoring your models, then you're really losing out on money on all these investments that you're making within machine learning if you're not really monitoring your models. So you should monitor your models if you want to make sure that you're at least recovering all the investments you're making within machine learning. What are these operational ML risks? We'll go through this a little bit faster, given this a whole lot of operational metrics and risks that you might want to monitor for. So models, as we spoke about, they can fail silently and they can fail a lot. And there's these 5 key reasons to account for within the operational risk. One is their actual performance can decay, because of the fact that they've been trained on certain data, and live data can be really different. And data drift is this change in data that leads to performance changes that you need to track for and ensure. If that is the case, you need to retrain your model. Data integrity is when your model is seeing data issues that might be much downstream from where you're trying to catch it. And so because there can be complex data pipelines, your model will see data that's incorrect data, but your model will still make a prediction and it might not fail, and you just won't know it. It will take away from models performance like slightly over time. And so you might want to catch that ahead of time. Fourthly, bias is a key operational issue that teams have started to face. And here it's mostly because the data that's being chosen to actually train a model, it can have bias, it can have selection bias. And on top of it, when you train a model, the model can add or amplify like kind of bias. And if you're in a regulated use case, or if you're worried about let's say brand risk, you might want to look into this. And really lastly, because models can be opaque, it's very hard to explain why they're making a decision. And so that's one of the things that causes lack of transparency. We'll talk about this a little more. Because these models are becoming increasingly complex, there used to be logistic regressions, decision trees, now they're increasingly random forests or deep learning models. That makes it very hard to understand how the model is working and how it's making a decision. And as a result of that, it's very hard to figure out how's the model doing kind of performance wise. How do you monitor this model if you don't really know what it's doing? And how do you explain this model behavior? And it's not something that's only a data science problem. It 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 kind of touches all these stakeholders, internal stakeholders of a model, and external stakeholders of a model, whether you are a business user, whether you're actually customer support, whether you're IT ops, or whether you're an auditor in a bank or a regulator trying to validate a model that's a regulated model. So the fact that models are becoming increasingly opaque creates a problem for all these stakeholders. And there's also existing regulations. These are the historical regulations that apply to banking, the likes of Equal Credit Opportunity Act, that historically apply to quant models that might have been used and now, of course, are being applied to AI models if they're used for lending. There have been regulations that passed after the actual financial crash in 2008, also called SR 11.7. It's more of a guideline that states that banks that release their models need to know how they're working and actually monitor them. And recently, there have also been a whole bunch of proposed AI regulation, which are focused on AI specifically, that are trying to build more accountability and trust within AI. So we'll see a lot of these regulations come up and likely be passed in the coming years. And I've just shared a few of the issues from the AI from the bias kind of standpoint that we've seen in the past couple of years. And so these have driven a whole lot of chatter into proposed regulation that we'll start to see soon. So what does model performance management really mean? So in kind of traditional DevOps world, you have the notion of APM, or application performance management, to ensure that you know that the application, let's say your web applications really work well, and you've got visibility into it. Similarly, within the context of MLOps, you have a notion of MPM, or model performance management. So they are analogous. And so why do you need something like MPM? Within MLOps, the workflow is really iterative. So you don't just build one model. You first train a model, then you validate the model to ensure that you know how the model is working, that it's working on the right segments of data, that you've got the right kind of bias metrics on it, and then when you deploy it, you ensure that you're monitoring it across for drift and so on. And if it runs into operational issues, then you analyze it. Now, typically when you train a model, you take a fixed training set, which you think is representative of the data that the model will face once it's really deployed. But once the model is deployed, the reality of the model might change. So it might see new data. And so that data is not something that the model is really trained to make a decision on. So the model's performance goes down. So it's a constant iteration where the model's performance, it converges on high performance, and then it actually diverges. So when it diverges, you've got to have monitoring to actually ensure that you catch when it's starting to diverge, and then you analyze why it's diverging. If it's due to a data issue, then you can catch the data issue and then you can fix it. Or if it is due to shifts in data, then you might use it to drive improvements into your new training set, and then build a new model and compare that model with the existing model and see if it's truly making the performance better. So this is very different from the traditional DevOps kind of workflow where you actually deploy something and then you wait until something breaks or you have a new release. But in case of MLOps, your model's performance is constantly moving and kind of potentially decaying. So you need to have a way to keep on it, to have visibility into when it starts to decay, And when you train a new model, you can compare this new model with the old model. And so you need this visibility across the entire workflow. And you also need to understand how models are changing over time, so you can ensure that the performance is actually going up, and you've got a better understanding of that. For example, like let's say you've got a model that's, let's say, potentially a lending model, and your bank operates in 5 states, and now you've got a new kind of charter to operate in a 6 state. So now you need to create a new model that can now incorporate loans made in this new state. But you want to compare it with the existing model that's operating in really 5 states. So you need a model you need the understanding of the new model, and you need to understand it in the context of the old model, because this is very iterative. So that's why you need MPM to track all of this across all the parts of the MLOps lifecycle. And yeah, this is just reiterating what we just went through. So really, what that means is when you're training a model, you're logging all your training sets into NPM, and you're checking for bias. You're assessing feature quality. You're trying to validate for the model and slices of kind of performance, and explaining how's the new model changing versus the old model in a slice of interest. Then when you deploy it, you kind of deploy it. If you're running in, like, let's say, champion challenger mode, you can compare that. And then you can monitor for operational issues, drift, outliers, bias. If you have a slice or a segment of interest, you can even monitor that and see how, like, let's say, for example, how are your loans doing in one state versus all the states. And then finally, you can analyze them. If you run into operational issues, let's say you have drift, what's causing the drift? If you have, let's say, data integrity issues, what might be causing the data? What's the root cause of that? And that feeds back into training, where if you figured out that the data is changing, you might want to take that insight and train a new model with enhanced data that kind of augments the existing data for this new data slice. And so MPM sits at the heart of your MLOps lifecycle, and it records how your model is doing, gives you visibility into all these aspects, so that you can help maintain highest performance of your model as it diverges and converges on performance. So how do you catch operational issues? I'll go through this very briefly. So you can, if you have labels coming in, of course you can monitor for like the actual metrics like accuracy, or if you've got a regression model, you can monitor for MSE, or if you've got classification, you can monitor for, let's say, log loss. And so a monitoring solution would be something that will help you catch this, and you can set up alerts on this. So on the left, what you see is monitoring for all these metrics. So in this case, you can see accuracy, false positive rate, and so on. And you'll get a notification, or you can just spot it visually when your model in this time series way is actually decaying, and you can jump on it and see if it is something that you can resolve right away through a fix in the data pipeline or through a model retrain. If you don't have labels, coming in, which is likely the case, or they might not be coming in real time, then you can use a measure of comparison of your shift of data to figure out that your model might be losing its actual predictive power. So in this case, we use a measure of drift, which really gives you a measure of how is the data different from what you trained the model with what you're seeing in production. So, and here you can use a bunch of a whole let's say bunch of like kind of metrics here. You can use PSI, which is a typical metric used in financial services that tells you what's the distributional shift, and how do you really quantify that? Or you can use the likes of KL divergence or GS divergence. And so this will help you if you plot this, it'll help you understand that the data is shifting. And so what you can see on this chart is the dark blue line is the prediction drift. So the model's output. You can spot a drift in the output of the model. When this dark blue line jumps, you know something might be going wrong with the model, even if you don't have labels. And so you can deep dive into that and really try to figure out if that might be something um, really that's an issue that you need to solve with like a model retrain. And yeah, so a lot of times models also run into operational issues because they see data issues, and these are really like, let's say an input feature has a missing value, or an input feature has a range mismatch or a type mismatch, right? It could be, for example, that like going back to the bank example, your bank operates in 5 states, but your model is seeing a 6th state that was not used in training. So that might just have kind of leaked in. And so you want to be able to catch that because your model might not throw an error. So, but it'll make a prediction that might not be the right prediction. It might be slightly like lower than the accurate prediction. So the ability to figure out and catch these issues as they happen in like a time series way, so you can jump on it right away, will help you like catch these data issues like right away, so you can solve it right away and really like make sure that the model performance goes kind of back up high. Talking a little bit about bias, so it's so we spoke about how selection of data, is prone to bias. How training of a model can add bias or it can amplify bias. It's also possible that data shifts can introduce operational bias into your model as it's running. So you want to monitor for a segment or maybe a protected group for certain metrics as the model is running. So you can set up alerts and say, let's say, for example, true positive rate or false or true negative rate skews. And that is a metric that you're using, like a loose metric for variance in your bias once your model is running. If that starts to like skew and deviate, then you can jump on it and see what might be causing it, and you might then want to take action on it. So once you catch all these operational issues, how do you then improve model performance with it? So one way that teams do this is when they launch a new model, a challenger model, they monitor it with the existing like really champion model, and so they want to reduce the risk that the new model might add, given that they are trying to replace the existing model with the new model. So once you've trained this champion, once you've trained the actual challenger model, you want to compare and analyze how is this new model doing in the context of the old model. So in this case, what you're seeing is you're looking at, let's say, feature impact of the new model, right? Let's say version 2 model, and you're comparing it with a version 1 model. And so now you see how is the model, what is the feature impact of all the features of this new model versus the old model pre-deployment. And once you're confident that the new model, you understand how the new model behavior is working, and then you deploy this. And that's where once it's deployed, it can be in like shadow mode, or you can replay traffic, or you can do an A/B test on it. Then you can run it side by side, and you can compare how is this model doing on certain metrics across the board. And so you can run it side by side. And so that can give you operational insights that will help you figure out, hey, this new model, is this working well, or if it's having issues, right? What are some of the ways in which the old model's insights can help you fix the new model? And it could be new data. It could be some existing data issues that you might want to fix, and so on. And you could also monitor a segment for learning how the model is doing in the context of a cohort, right? So how does, let's say, for example, I have a banking model again that's making loans across all states. How is this model working in the context of California? Loans made in California, which might be the highest, which might be the highest revenue kind of state in the bank. And so you might want to compare that, segment in the context of the entire model, so that you can improve the model based on the behavior. And once you figure out an operational issue, and I'll spend just a final minute on this, and then see if you have any questions. So explainability really helps you understand why the model is making a decision. That helps you understand behavior and root cause issues, and that can help you make the models better. So there's three kinds of explainabilities. One is, or three ways in which you can apply explainability. One is locally explaining a prediction of a model, in this case, a specific loan, or at a cohort, or let's say a segment level, we're explaining a slice of like predictions, or globally, we're explaining all, like the entire model in the context of data, like feature importance at the global level. And so explaining a prediction can really mean understanding, like let's say in this case, model is predicting a high risk loan of 0.235, and really debt to income, which is one of the inputs, contributes the most, close to 20% to this model prediction. And you use techniques like Shapley values and so on to really calculate this. Doing this in the context of validation and debugging really helps you gain insights into the model behavior to help you improve this model and keep it high performant. And this is an example to explain a text model output. And this is how you can think about explaining a segment or like the entire model. Once you've explained a prediction, how do you explain a group of predictions and a global, and explain the model globally with like a bunch of these charts, like let's say PDP, like chart, feature impact chart, and kind of putting it together. You can use explainability in the context of monitoring, so that you not only get visibility into operational issues like drift, and this is the drift chart that we've kind of reviewed, where the deep blue line represents the drift spiking. But you can then use explainability to really root cause why that might be happening. So you can click on this day window where it's spiking, and you can use explainability using feature impacts to understand which of the features is causing that drift, and then drill down and root cause using cohort analysis to understand why the drift might be happening. So that's how explainability kind of plays a role into maintaining high performance of a model through like troubleshooting, debugging, and validation. So I'll pause there and see if there are any final questions.
Hey, Amit, thank you so much for a very great presentation. So if the attendees, if you have any questions, please feel free to ask them in the chat. So maybe we can kick it off by, you had mentioned kind of like it's really important to kind of analyze your performance across like different segments, and kind of that helps with the improvement of the behavior and kind of other topics. Like if you can touch on more on like why do you think it's more important to kind of analyze it across the segments?
Yeah, so typically what we see is when you've trained a new model, you typically have a few problem instances, right? It could be problem loans that you want to run it through. It could be potential areas of interest or segments of interest that you want to make sure these might be high revenue or these might be high risk, right? And so typically understanding how the model is doing in the context of those individual inferences, as well as the cohorts, helps you gain confidence that you know how the model is working in the highest risk areas that you've identified in the past. What you can also do is you can figure out what are the new risk areas. For example, you've trained a new model, right? What is the segment that's now the lowest performing in the model? And then you can use that insight and actually compare to an existing model or see if that insight makes sense. For example, you could have limited data that might be driving lower performance of a certain segment. And so you can then think about potentially adding new data, or you can think about potentially retraining on like a new on like a different model, like let's say algorithm. So helping so understanding how the model is doing in the context of not just individual like kind of predictions, but also these regional levels helps you glean model behavior from really different from really different facets, and also in the context of the existing like kind of model, so that you can ensure that the new model is at least giving you as much performance and then some.
Totally. So you mentioned about kind of upcoming kind of regulations and kind of guidelines that are coming now for explainability and kind of monitoring. Like, what do you see, or like what kind of industries do you think that are kind of like better prepared now to meet those guidelines? And like maybe if you can touch on some of the shortcomings of kind of how practitioners and kind of businesses can.
It's a great question. I can talk about the recent EU regulation. It's like an 80-page regulation. It makes for a good read. They've classified AI systems into 4 classes. And the second class is high risk, right? One that's, of course, that's banned, and then low risk and so on. But the high risk ones, they classify high risk AI systems as ones that can make a meaningful impact in like a person's livelihood, and then they have a bunch of like kind of defining criteria there. And one of the use cases there is lending, right? That can make a meaningful impact. One of the use cases is also recruiting, right? That can make a meaningful impact. So in these high risk use cases, what the regulation says is you need to understand how your model is working, because you want to make sure that you're removing as much risk from this model by understanding it, so that you know how it's going to work when it's deployed. So that's one part. The second part it says is you need to monitor these models. You have to give the ability for somebody to stay on top of this model when it's deployed, because the model can deviate, right? You can validate it for a certain context, but it might not hold. And this could be autonomous cars, right? It might not hold. The world might change. And so it says you need these 2 things. You need to ensure that you understand model behavior so you can explain it and understand it for yourself, and then you can monitor it. I think the industries that are well prepared for this are the ones who already take care of this due to existing regulations. And that's, of course, financial services, recruiting, and healthcare. But those same processes and guidelines, I think they can be expanded and extended to other industries as they're like really deploying, because some of the issues that these regulations are trying to solve go beyond just these three industries. So I think the rest of the industries have like a great opportunity to learn. Like, for example, MRM is like a process that kind of banks have in place, right? For AI models. It used to be existing quant models. So yeah, there are existing industries that are well kind of suited for this, but it would be great if those processes are adopted and expanded to the rest of the industries.
Oh yeah, absolutely. Yeah, like just given that how much penetration is kind of the algorithms are having just across all of the industries, right? So like I think it definitely makes sense for everyone to kind of, as they're building it, like have this discussion prior to the build, to not think of it as something that we need to look at it after it's been deployed and monitoring, but think of it as prior to, like, as you're building out the use cases. And
correct. And in the context of the EU regulation, they also say low risk AI system, let's say spam filters, right? Like low risk. They recommend teams who might be having high risk and low risk at the same time. They recommend teams to put all their use cases through the same processes that they might have in place for high risk, because that just gives the teams the ability to ensure that low risk systems also have the same measures in place, and it's like a unified process in place.
Absolutely, yeah. So we do have a question from the audience. There's a question from Chloe, and they ask, how do you evaluate, monitor deploying models where the prediction might affect the outcome? So in case of example, in the case of churn deduction, your model predicts that a customer will leave. So you intervene accordingly and prevent the customer from leaving. This will look like a false positive. So how do you kind of mitigate that?
That's a good question. I think that's a good question. I think there needs to be some way in which the human in the loop interventions are accounted for as insights into potentially an updated training set. Because like in this case, it's not like the model is making a wrong prediction. The model is stating somebody is high risk for churn. And in fact, the model is right. That's why the human is intervening. So I would say it depends. It kind of depends on a case by case basis. Typical monitoring solutions will account for the fact that the model is making the right decision, right? But at some point, there's also human in the loop that's negating the effect of the model altogether. For example, if the model says it's fraud, but the human in the loop says no, it's not fraud, then that's a stronger signal that you can feed back into your system and kind of potentially account for it as you build the next model. So in the churn case, I would think that the model is making the right decision. Maybe interventions might be used in some way. I can't seem to think of some way in which that would impact the model's training itself, but maybe there is. Would kind of love to learn more there. But in the case where the human in the loop is actually, negating the effect, then that is a pretty strong input for the next model retrain, because your model is not making a right decision.
Mm-hmm. Totally. We have time for one more question. So it looks like Adrian's asking, is it possible to manipulate custom metrics such as aggregation and ACUs in programmatic manners such as notebook style and so on?
Yeah, that's a great question. That's one of the top capabilities we get asked, because you can only offer so many metrics built in, right? Teams typically have might have their own custom metrics. One kind of basic way in which you can build custom metrics for any platform that you look at is there might be some metrics that just come built in, right? Let's say averages, let's say percentiles, or so on. A way in which you can programmatically create a metric on the top of those existing aggregate metrics. So that's one way, and you could define that in, let's say, SQL or so on. But you could also have, let's say, a UDF, or user-defined function, that represents some metric that's built on top of the existing aggregates, like the existing aggregates. But kind of typically, these metrics are built on top of existing metrics that are already offered. You can't create new metrics that will cause, like, let's say, a new aggregate being kind of built. But if that is the case, you can work with kind of like these kind of platform teams and make sure that you support. But I would caution against using something that's so custom, that like maybe you might want to take a look at existing metrics that already exist, that might serve your purpose. But kind of typically, the custom metrics are built on top of existing aggregates metrics. For example, you might have a custom measure of AUC. You might have a user level AUC, right? Not an aggregate AUC, but you might want to track it by user level. So that's an example of something that's built on on top of an existing like really metric. So yeah, it's like a long way of saying, yeah, you should be able to support custom metrics, but there are limits to what you can support. As long as it's built on existing aggregates, a lot of platforms should be able to support that.
Really perfect. Thank you so much. This has been a wonderful conversation, and I hope the attendees were able to take away some key metrics. Just before we close, how can they get in touch with you or kind of the Fiddler team as well?
Yes, I just shared my email address, amit@fiddler.ai. Feel free to send me a note. I'm happy to connect you with like the rest of the team, the data science team or the eng team or the sales team. And we are happy to answer any questions. We've been talking to a ton of customers that are running into just kind of challenges maintaining performance of these models as they scale up the number of models, as a lot of teams are. And happy to share insights if that may help some folks here in the audience.
Absolutely. And I think Jesse just mentioned that the team is hiring. So please do visit their website and please do apply as well.
Yeah, we are hiring across the board. Feel free to kind of send me a note on that if you find any role on the website that might be appealing to you, or if you have a referral, feel free to please send me a note.
Perfect. All right. Thank you so much for your time, Amit. And thank you, everyone, for joining the session.
Cool. Thanks, everyone.